Yeah, now let's work out with another important area for the large infrastructure projects, which is something to do with the depreciation. And just to understand, depreciation is more of allocation of the costs over the period of usage. So how can I allocate the cost of, let's say my project was costing close to, how much was the cost of our project? Our project was costing close to 121 crores during the construction period. So for this 121 crores, probably I would have used, out of this 121 crores, probably we are breaking this 121 crores across the various assets, right? Or probably I may not look at this entire 121 crores, or probably the entire 121 crores in the initial years, which is the total cost of the project. Let's say I am allocating it over the remaining 31 years of the project, right? I am allocating over the remaining 31 years of project based on some basis. And what is the basis? If I go down, we have made a few assumptions regarding our assets. We have made that our assets are primarily relating to building and civil works, which constitute 80% of the total assets, and probably furnitures and fixtures, which will be composed of 10% of the total assets, and plant and machinery the remaining 10%. Whatever are the assets, I am assuming that they are split, let's say, in this particular proportion. So the depreciation also, whatever I would like to do, whatever I have capitalized, all those costs I have capitalized, which means I would typically allocate those costs over the remaining years of the asset, over the remaining years of the usage of the asset. So the way I would like to look at is, I'll create another new sheet called as the depreciation sheet, right? This is my depreciation sheet, and a few things will be common, as we have done even in case of any of the earlier things. This part I'll take it common. If this is blank, treat it as blank, otherwise fill it with this value. So this portion will be the same across, and probably this is not required. I will drag this up to this AZ. The same logic which we have extended it, which we have did earlier, will perform the same kind of a scenario here. Now that we are talking about depreciation, which is the allocation of our cost. So now that in our assumptions we made that primarily our assets are divided across these three elements: building and civil works, furniture and fixtures, plant and machinery. In some of the cases, we may have a slightly different set of the assets, whatever it is, right? So I may talk about here a straight line depreciation. How do I differentiate it? We have two forms of depreciation. One, I'm looking at a straight line depreciation, as in this, as I have listed out here, and I'm also interested in written down value. Why? These two types of depreciations are very much required for almost all kinds of projects. The reason is when I am preparing a P&L statement from the financial reporting standpoint, I'll use a straight line depreciation method. But when I am preparing a financial statement from the tax reporting standpoint, I have to use the written down value based depreciation. So, in a simple scenario, the written down value based depreciation will depreciate the asset much faster compared to the straight line depreciation method. And in a straight line depreciation method, the allocation is uniform across all the years of the project of the asset. Whereas in a written down value, we allocate more depreciation in the initial years, whereas the depreciation keeps going down in the later years. So we'll just try to understand how we model this depreciation for these three kind of securities or these three kind of assets. The way I would like to look at it is, I know that their worth is split, so my total cost of the project I would split in the ratio of this. So what I could do is, in my construction itself, I could create a breakup. I will create another area called breakup of assets, wherein now that I know that I have three types of assets, I'll pull them from here itself: building and civil works, and if I drag a little bit down, I have furnitures and fixtures and plant and machinery. So what I'll do is, I'll take my total project cost and multiply it with this. So my building and civil works is around 96.6 crores. The furniture and fixture is worth somewhere around 12, and plant and machinery is somewhere around 12 crores. So what I could do here, so that is the total worth of the assets which have to be depreciated, because the usage of these assets come only from the operations phase onwards. So I'll try to use these things from the operations phase. So when I am doing a straight line depreciation, it is said that for building and civil works, the straight line depreciation percentage is 3.34% of the total asset value. So what I would be doing is, logic wise, now let's try to work out on the logic. So 3.34% of the asset value. So let's say the asset value is 100, just giving you a small workout. If the asset value is 100, so for the first year I'll put 3.34 as the depreciation. The second year I'll put 3.34 as the depreciation, or for a simplicity purpose, yeah, okay, for the second, let's take 3% just to explain the concept. So for the first year I'll put 3 as a depreciation. For the second I'll put 3. Like that I can put 3 for 33 years. And for the 34th year, right, for the 34th year, 99 has already been allocated, means the only number that is left is 1 to match with the total value of the asset, which means in some years I will allocate 3 until the value is total value depreciated is lesser than the total value of the asset. Wherever that is lesser, I'll take the balance, and from the next year onwards I'll take it as 0. So the simple way of looking at it is, I will simply take the number of years, right? I will divide the percentage. If it is given as 3%, what I'll do, I'll divide 1 by 3%. So this comes out to 33.33. Right, this comes out to 33.33. I will take up the roundup of this number. Right, I will take the roundup of this particular number, which means 34. Right, I'll take the roundup of this number, which is 34, which means for the first 33 years, I will take the depreciation as, or probably I will take the next higher integer. So all I can say is integer of this 33.33 plus 1. I'll take the next higher integer. Means if it comes to 34, what I'll say is up to 33 years, I'll take this percentage times the asset value. For the 34th year, I'll take the balance between the asset value and the total depreciated for 33 years. And for 35 onwards, I'll take the depreciation to be 0. This is the simple calculation I would do to allot the straight line depreciation across all the years. Right? Now, so going with that typical logic, and here I have 2 years of construction period. So the depreciation is literally not applicable for the construction period, which means I have to look at year numbers plus the number of years of construction. So let's try to build in the logic now. Okay, I'm saying if I have to do it here for the straight line depreciation. So I'll build a logic saying if this is equal to O, which means the operations period only. Otherwise, I will replace it with a blank. So 1 if it is operations, and if the year number is less than 33. How did I get that 33 here? If the year number is less than the integer of 1 divided by whatever is the depreciation rate. 1 divided by whatever the depreciation rate. So here I'll put a dollar for B, and here I'll put a dollar for 2 to block the location. Okay. If the year is less than the integer of 1 by the depreciation rate, 1 by 3, 33.33, integer of that is 33. So plus 1 plus the number of years of the construction period. So as long as the year number is lesser than this, right, as long as the year number is lesser than this, what is that I'll do? I will take the depreciation as the depreciation percentage. This is my depreciation percentage. So here also I will put a dollar for B multiplied by whatever is our amount that is allocated to this building and civil engineering works. So here also I will take a dollar. So up to that number I will take the multiplication of the depreciation rate, because the full value is depreciated. Until those many years the full value is depreciated. Otherwise, if The same logic, if the B1, probably the same thing I can use, if this year number, right, I can very well take if this particular year number is greater than, if this particular you have a number is greater than the same logic, or probably, yeah, we can do it equal to or even greater than, either way. If this is greater than this particular, because we have three options coming out, if this is greater than this, so what should I do? The depreciation should be shown as 0 itself. If it is greater than that particular value, the depreciation need to be shown as 0, and otherwise the depreciation need to be shown as the gap, which is nothing but the asset value. What is the asset value? This asset value here I am taking a dollar here, the asset value minus whatever has been depreciated till date. So which is nothing but 1 divided by, so the integer times 1 divided by the assumption B36. So whatever, for these many number of years multiplied by the depreciation amount. So whatever has been depreciated till date, the integer times whatever has been the depreciation amount. So this has been the periodic depreciation amount. So I will even consider this multiplied by this. So this is what will, so probably you have to be slightly careful in terms of handling all these dollars and everything, right? Once a slight comfort comes in the usage of this formula, you can very well go ahead in terms of dragging it across, right? So now all it is coming out is, yeah, the final thing that is missing out is, in case if that is blank, if it is not equal to the operations phase, we have to keep it as a blank. And similarly here also we need to look out for, in case it is not greater, or in case it is not lesser for the other period. Okay, here I don't need anything, so probably here this is being shown as a blank, and now when I drag it, yes, 3.22 is the depreciation for this particular period, dragging it. So yeah, 3.22 is the number that is coming across, and I drag the same until the AZ. So until a specific year, yes, the last but one year it is coming out to 3.033, and in the 33rd year it is coming out to 0. And if you see the summation of this entire, it is coming to 96.6, which is equal to the worth of the asset itself. So which means we have got the formula for depreciating correctly itself. So we are dealing with these three situations. Drag it down, yes, working for plant and machineries also. Drag them to the right. These are the depreciations that are applicable for each of these periods. And now what you could very well see is the second one, because of the depreciation being around 6.28% or 6.33%, what we are seeing is the second one is depreciated much faster the same 12.07, which is the total sum, probably by the 17th or 18th year itself it is fully depreciated, whereas the third one, even there also the sum is the same, it is depreciated within 21 years. So this is the way we are allocating the costs across the various years. So this is the typical application of the straight line depreciation method. So we can even put the required formatting on it and bring out that these are the depreciations, and if possible we should also look at computing the total straight line depreciation value. Total straight line depreciation. Again the same logic, if this part is equal to the operations, then I'll do the summation of all these, otherwise I'll leave that as blank. So the same logic working across, right, up to AZ, all this will remain the same. We are coming out with this particular number, and the formatting is being something like this. So this is what is the total straight line depreciation for this particular period. Now when we are getting into the written down value, of course we'll discuss about how we address these two things as a part of our taxation part, right? But just to understand what kind of difference each of these things are creating, all I can do here is I decrease each of the year's asset value by 10% every year. So what would typically happen is, to the asset value, probably the first year the 10% of the asset value is depreciated. Then out of the remaining balance, right? So what is the remaining balance? 1 minus 10%, 1 minus 10% of the asset. So the way I would look at is, it's like this. Probably if I have to explain the written down value method here, okay, initially let's say 100 is the worth of the asset. For the first year of operations, the written down value method of depreciation is 10 if the depreciation percentage is 10%. So the asset that is remaining is 90 at the end of the first year. Asset that is remaining is 90. So the depreciation will be 10% of this 90, which is 9. Then the second year the asset will be worth 81. So the 10% of it will become 8.1. So in a general way, how can I write it? 1 minus the depreciation percentage. This number I will take to the power of, let's say 0 if it is the first year, 1 if it is the second year, and 2 if it is the third year of the value of the asset. So which means 1 minus depreciation percentage to the power year minus 1 times the value of the asset. Then this is multiplied by the depreciation percentage. But here we have a construction period for which the depreciation is not applicable. So even the construction period also I would remove from this particular factor. So basically whatever the mathematics we are trying to put it into our calculation, we are writing the appropriate formulas to address the same stuff. So probably if I have to come out with that in my spreadsheet, all I can say is yes, if this is equal to operations only, it is applicable. And what is that I am applying? 1 minus, what is the depreciation percentage here? I have to make sure that I am handling the dollars quite comfortably. 1 minus the written down value depreciation, where C is something I will freeze. Written down value depreciation to the power of year number. So raised to the power of the year number. This is the year number. So here also I'll put 1 for the dollar for the 1, minus 1 because year number minus 1, minus the number of years of construction period. You have to be very careful in each and every step. So this is the 1 minus depreciation to the power year number minus 1 minus 2 multiplied by the value of the asset. The value of the asset is coming from here where I can block my B, multiplied by the depreciation percentage. Depreciation percentage again is coming from the written down value depreciation, where again I can block my C. This is the case if the whole thing is equivalent to the operations period. Otherwise, I will represent it as a black. Okay, so this is with respect to my civil works. Take it down, plant and machinery, drag it to the right. Yes, there is a 10% of each of these things, or probably for the building and civil it is 10, for the furniture it is remaining. So the best way for us to check out is go till the last, even up to the AZ period. I should notice that the values are declining period over period, right? To a large extent, there is a huge amount of asset that has to be depreciated. Almost 117 crores of the asset is depreciated by this time frame. So these are the values of the asset in each of the, these are the values of depreciations for each of the years. If we see for the building and civil works, almost 92.93% is depreciated, or 92.93 crores is depreciated. For furnitures and fixtures, 12.05 crores is depreciated, whereas for this 11.99 crores is depreciated. So I could also find out total written down value method of depreciation. Same logic I can use. If this is equal to O, then do the summation of all these values, otherwise leave it as blank. So the financial modeling, as I am showing right now, it's an art with respect to the playing with the Excel formulas to get as much of dynamism as possible. So because that is what will help you in doing your what if analysis quite comfortably, bringing in as many scenarios as possible into our analysis. So this is the total written down value based depreciation, and what you could see very clearly is in the initial few years the straight line depreciation is much lesser than the written down value depreciation. Probably for the first 11, or probably even in the 12th, or probably in the 11th or 12th year, you are seeing that the written down value depreciation is slightly lesser than the straight line, but in the initial few years the straight line depreciation is much lesser than the written down value depreciation. That is what will create a scenario of tax advantage. We'll talk about these two things when we are discussing about the taxes, but for now we have to be comfortable in terms of doing the depreciation by these two mechanisms, because this one will be used for presenting the financial statements, computing the profit after tax and all those things. Whereas this mechanism will be used for us to go ahead with computing the tax amounts and dealing with corporate tax as well as dividend distribution tax and all these elements. All right. So I hope how we incorporate the depreciation or how we create a structure for a depreciation in the financial model is clear and is evident to you from this example. If you have any further queries regarding the same, you can very well get in touch with me by giving me a call on this number, or you can send in an email at vamsidhar@pacegurus.com. I can get back to you with the detailed solutions or clarifications to these questions. Thanks a lot for listening to this session. Thank you very much.